So there was query as to why I wrote this. So we're used to seeing a plus b to the power n in our general formula, in our general rule. So in this case, a is actually 2k and b is minus 3. And we could also add n here. What would n in this case be? 5. Okay, so these are the three pieces of information we need when we're expanding using the binomial expansion. We need to identify what's a, what's b, and what's n. And as I said the other day, the main reason it becomes more complicated is because we know we're raising these things to a power. So if we look here, if we had 2k all to the power 5, that's not just 2k to the 5, it's actually 32k to the power 5, because the 2 is raised to the power 5 as well. And the fact that it's negative 3, we have to be careful when we're squaring it, or more importantly when we're cubing it, if we're cubing it, because we need to see what sign it is, because we know negative 3 squared is actually positive 9. Now we also, and that also brings into the fact that we've got these numbers that we're dealing with. Okay, so no longer are they just letters, they're not just x and y that we've been used to, they're actually numbers. But we also have Pascal's number that we have to deal with. Okay, so at the moment it may sound a little bit crazy, a little bit hectic, but it's actually, we just follow the same methodical system and you will be fine. Anyway, I can't remember what all that says, but you can read it later. So if we're writing the first 3 terms of this expression here, what did we say happens? We start with 1 as our first coefficient, because that's always the first thing in Pascal's triangle. And we're going to multiply that by term A, which is 2k to the power 5. So remember, the first term always has the same power as the expression. And then the negative 3 is to the power 0. Plus, at this point I should have actually established what my Pascal's triangle is for row number 5. Does anyone remember any of the numbers in Pascal's triangle? More than 1? Do we at least remember 1, 2, 1?
1, 3, 3, 4, 6, 4.
Okay, so hopefully you can all see that this is the row that we want. If you remember, or maybe not, it was a whole weekend away, the power is always going to be the second term. Okay, so we're looking for this one here because 5 is our power. So we've got our coefficient. So now we know that this number here is a 5. And then what's going to happen to the 2k term? It's now to the power 4. And negative 3 is now to the power 1. Remember, what did I say about these powers here? Remember? 1 goes up, 1 goes down, but what's special about those numbers in particular? 5 and 0, 4 and 1, they always add to give that 5. And they don't want the first 3 terms, so our next term has a coefficient of 10. We've got 2k to the power 3 and negative 3 to the power 2. Now that expansion could keep going on, so really we probably should have put dots at the end to show it keeps going, but they only want the first 3 terms.
Why is it 1, 5, and 2?
Because we established here that was our Pascal's triangle number. Okay, I think you explained to Aaron at the time. Alright, so now we need to start simplifying stuff. Negative 3 to the power 0 means that that's just 1. This is 1. So all we have to deal with is 2k all to the power 5. So that's 32k to the power 5. I would suggest at this point you want to go in baby steps. Don't try and do too much too soon, especially if it's on a long calc paper, because that's when you could start making errors. So I'm going to keep this as plus 5. And now I'm going to expand 2k to the power 4. So what's 2 to the power 4? 16k to the power 4. And then we've also got negative 3. I no longer need to write to the power 1. Plus 10. What's 2 cubed? So this next term is going to be 8k cubed. And negative 3 squared is positive 9. Okay, so as I said, baby steps as I went forward. So 32k to the 5. Now I have to start multiplying some numbers together. So I need to multiply my 5 and 16 and negative 3. Does anyone know what that is? Maybe we can have calc here. What's 5 times 16 times negative 3? So no one's got a calc at all in the world. Negative 240?
Yeah.
And the next one we can do because it's times by 10. So what's 8 times 9? Times by 10.
720.
Okay, unfortunately Cameron shouted out the answer a little bit after I'd already asked the next question. But we're good to go now.
Thanks for putting my blast in
Alright, another example. So we're giving the first 4 terms of this. So we need to know the correct row of Pascal's triangle for this one. I'm going to carry on working from the example up above to find Pascal's triangle. So after 1, 5, 10, 10, 5, 1, we have 1, 6,
15,
15,
20,
20.
15, 6, 1,
That's lovely. And
7, no, 1, 7, 21, 35, 21,
secretly 35 again.
35, 16, 21.
Did you stop telling me?
8.
46. 70.
Okay, really proud of everyone. Thanks for that. Alright, so this is obviously the row we're interested in. Because it's to the power 8. They only want to know the first 4 terms. So, the first term is going to be 1 from Pascal's triangle times 1 because that's our term A times 2x to the power 0. I apologise. 1 is to the power 8. Plus 8 times 1 to the power 7 times 2x to the power 1 plus 28 times 1 to the power 6 times 2x to the power 2 and 56 times 1 to the power 5 times 2x to the power 3. So that's 4 terms. So these 3 terms are all equal to 1, so that's 1 plus 8 times 1 times 2x. It is, sweetheart, but 2x to the power 0 is 1. Plus 28 times 1 times 4x squared plus 56 times 1 times 8x cubed gives us 1 plus 16x plus 112 x squared plus, oh gosh, 448 x cubed. Hopefully they are all correct. No. Pascal's